All right, here we go. Mid-chapter review, problem numero 5. We got the stupid cart with wheels, right? So let's see. The cart has a total mass of 2.5 kilograms and it has wheels that each have a mass of 0.3 kilograms. So let's do this. Let's make a careful list of our masses. So the mass of the cart's body and the wheels combined is a total of 2.5 kilograms. The mass of just the wheels alone is, well, they're 0.3 kilograms each, but there are 3 of them. So that's a total of 0.9 kilograms. So subtracting allows us to find the mass of the body, which you may or may not need depending on how you solve it. But I just want to point out that there are sort of 3 different masses to think about. The body, the wheels, and then the combined mass. Okay? So that's our starting off point. All right? Now what's going to happen is we've got this cart that's rolling. It tells us that the incline here is 30 degrees. And that the cart, when it first gets here, it's moving at a velocity of 6 meters a second. And at that point, the height is 0. And the question wants to know, how far does it get up the ramp before it gets to this point up here, where the velocity is 0? And so the idea is if I can find the height at that point, then I can use some trig and find my displacement that it went, right? Okay, so there are 2 points that I care about. We'll call this point down here at the bottom point A, and we'll call this point over here at the top, well, over here at the top, we'll call that point B. All right. Also important to notice, the problem tells us that the wheels are disks, and therefore our I is 1/2 mr squared, and so this is what our B is going to be, right? Is that 1/2. Okay. So at point A, so the whole premise, as is the case with everything here, the total energy at point A has got to equal the total energy at point B, all right? And at point A, we have no GPE, but we've definitely got some kinetic energy. So I'm going to be really detailed about this. So the kinetic energy at point A is, well, let's see what we need to think about. The base of the car has kinetic energy. The wheels of the car have kinetic energy. And the wheels also have rotational kinetic energy, right? So those are the 3 forms of energy we've got. The body has kinetic energy, the wheels have kinetic energy, and the wheels also have rotational kinetic energy. All right? So those all added together have to be equal to the total energy at point B. Well, at point B, all of our energy is just GPE, right? And that's the GPE of the body and the wheels. Okay? So let's figure this out. So the kinetic energy of the body and the wheels can kind of be combined, right? So that's going to be 1/2. The mass of the body and the wheels is 2.5 kilograms, and the velocity is given as 6. Don't forget to square it. Plus the rotational kinetic energy of the wheels. So let's think. That would be equal to the kinetic. It's B times the kinetic energy of the wheels. So our B is 1/2. Now, the kinetic energy of the wheels is 1/2 the mass, which is 0.9, times velocity squared. Okay, so that's this. Okay, and this whole mess equals the GPE at the top, which is just the mass of the whole thing times 9.8 times h. Okay. Now, from there, what do? Well, this whole red side here, we can simplify that mess. So you end up getting 45 plus 8.1 equals 24.5h. So you get 50, oops. So you get, oh my glob. You get 53.1 equals 24.5h. Divide both sides, and your h at the top ends up being 2.17 meters. So now we just go, oh, well, I've got a triangle. I know this is 30 degrees. I know the height is 2.17 meters. So do a little bit of trig, and you'll find that your hypotenuse here is 4.33 meters. Okay? So that is question A. Now, question B wants to know how fast it's moving when it's gone half of that distance. All right? Well, half of that distance also means half of that height, right? Like if we think about, I don't want to do this. If you think about a triangle that looks like this, here's the triangle we just found. So this height here was 2.17, and this displacement was 4.33, right? if I go half of the hypotenuse, that's also going to be half of the height, right? Because they're similar triangles. So half of 4.33 turns out to be 2.17, and half of 2.17 turns out to be like 1.085. All right? And so what I want to know is I want to know the velocity at that point there. Okay? So let's call this point C right there. Okay? So here is the deal. So at point C, I know the height is 1.085 meters, and I want to find the velocity at that point. All right? Now notice, I've already found the total energy at point A, right? Total energy there was 53.1. Cool? So here we go. Oops. So I want to do this. The total energy at point A is equal to the total energy at point C. So 53.1 joules is the total energy at A. That's got to equal, let's see, at point C we got a ton of things. We've got gravitational potential energy of the body and the wheels. We've got kinetic energy of the body, kinetic energy of the wheels, and rotational kinetic energy of the wheels, right? Okay, so let's see. So I'm looking at 53.1 equals, so let's see. This is going to give us, let's see, the mass is what? Why am I dumb all of a sudden? 2.5 times 9.8 times the height, which was 1.085. Okay. Plus, I'm going to combine these again. The kinetic energy of the body and the wheels. So, kinetic energy of the body and the wheels is 1/2 the mass of the body and the wheels times v squared plus the rotational kinetic energy of the wheels. So the rotational kinetic energy of the wheels is b times the kinetic energy of the wheels, which depends on their mass. Okay? So now we just got to solve this mess. All right? So here's what you get. You get 53.1 equals 26.55 is the yellow plus 1.25 v squared is that weird neon green color. This plus the blue part there gives you, hello, give me 1 minute, v squared, and then solve this mess. So what are we going to get? You get 26.55 equals 1.475 v squared, and solve for your v, and you get whatever the answer was on the sheet, 4.24 meters a second.